Hey, what's up everybody? How's it going? Welcome to TGIK. I am your host, Kris Nova, on this lovely Friday afternoon. And let's do everybody, well, it's certainly my favorite part of the week, but let's go ahead and do hellos from everyone. See who's all here and make sure everything is working good. Last time I was plagued with demo woes trying to get my stream up and running. So I had to reformat my entire hard drive, reinstall Mac OS X, get OBS up and running, and like, poof, everything seems to be magically working now. Oh my god, Jason said heyo. Wow, that's great. Okay, so let's see who's here. Okay, so we have Sebastian. Hey, we have Suresh. We have Marco. Good to see you again, Marco. Bob, good to see you. Thanks for all your help. Jason, Andy, good to see you. Philip, Joe, Caleb, Arnaud, Sebastian. I think, do we already have a Sebastian? No, there's two Sebastians. Okay. We have Caleb. We have Norman. Oh my gosh, this is like the part where it's like really hard to pronounce people's names. Don Shad? Aaron, good to see you. Neil, Mitch, Stevo, Yash, James, Eric St. Martin, one of my homeboys from Microsoft. Ria, my homegirl from Microsoft. How's everybody doing? It's good to see you all. So yeah, as folks join in, I'll try to give shout outs as they come. Good to see you, Ricardo. And I think we're just going to jump right in. I just flew back into Seattle from Denver. I was out at GlueCon all week. I gave a talk. Joe gave a talk. Ria gave a great talk on the virtual kubelet, which of course we're talking about today, that everybody's so excited about seeing. So I got in last night and came in today, and today has pretty much been all TGIK prep all day, so getting ready to do this thing. So first things first, I got my sweet virtual kubelet shirt on, courtesy to the folks at Microsoft who gave me a shirt at the KubeCon booth. It's a dude shirt, but it actually looks pretty good because I got it in a small, so rocking my VK shirt today. Oh, I also discovered that's like the thing now. Like everybody was calling it VK. Like it's not virtual kubelet, it's totally VK. So for the rest of the episode, I'll be trying to remember the acronym. So let's start off with live updates, kind of what's been going on in the week, and I have some exciting announcements for everyone. So let's switch over to my screen. Poof. Okay, thanks Mitch. It is a nice tee. I like rocking it. So this is exciting. So what we have here is a Heptio TGIK repository. So my co-author, Justin Garrison, and Joe were talking on Twitter about how folks wanted to maybe start contributing suggestions and ideas and start documenting TGIK. So I went ahead over the last week or so, and I created this new private repository, github.com/heptio/TGIK. And we've added our first episode, which is episode 36, the episode we're on today, in this episodes directory, and we're going to start tracking episode information here. So without further ado, let's take a look at this new repository. So we go here to the front page, and we have this fabulous picture of Little Tahoma Peak from the crest of Mount Rainier looking south out onto the mountain range, and we have this really handy Watch Live Now button. A lot of folks have been asking for this. So this is a great example of a pointer. So every week we update the TGIK Watch Live Now link to the pointer to this week's episode. So this should always work and go to the most recent or the upcoming TGIK episode of the week. So you can just bookmark this page and just come here and click the Watch Live Now button. And then we just have a really quick and dirty README. Folks, feel free to contribute. It's really easy to contribute. It's an Apache 2 license, and it's a great way to get some GitHub brownie points and start working with myself and other folks here at Heptio in open source. So if there's anything, I probably misspelled a bunch of stuff, so if there's anything you see, feel free to open up a PR. So for our first episode, we have a README file that has all of our links that we're going to go through that I want to talk about today. And it's got stuff on the virtual kubelet, it's got stuff that happened over the week, and it's got everything that we're going to bring up on the episode. Hi, James. Welcome from San Francisco. And I guess before we do this, we're going to open source this live. Like, we're going to do it live. So we're going to go to Settings, and we're going to scroll down here, and we're going to make this repository public. So we type TGIK. So I understand the risks Actually, I'm not going to type this on the screen. Let me get that out of there. Type in my password. Type in my correct password. The Kubernetes GitHub org has like some crazy security. There we go. Okay, I had to enter my code too. So moving this back over here, and I got shortcuts. Bam, bam. Looks like now Heptio TGIK is now a public repo. And we already have our first star. So who got our first star? Looks like we have Nick Doy got our first star of the GitHub repo. So from now until the end of TGIK, he will be #1 on the list for first person to star TGIK. Congratulations, Nick. Oh, we already have 3. Wow, this is going up fast. Anyway, check it out. And what we have here is the issue tracker. Good to see you, Mark. Welcome from Melbourne. Yes, my password is 123456. I have no idea how you all guessed it. Hi from Germany. Good to see you, Thorsten. So anyway, in the GitHub issue tracker, if you have an idea, this could be anything from, hey, we want you to do a full episode, to, hey, we just want a shout out, or maybe just like start thinking about something, or maybe I just heard of something and it would like for somebody else to kind of check it out. So you can come in and you can just open up a new issue. It's super easy. Just put whatever you want in there. We'll figure the rest out. We'll start imposing like crazy rules and unnecessary laws over time as they come, and we actually need that. And then we have a couple of labels I put together. We have updates, we have shoutouts, and we have episodes. And so as we filter through these, we'll start adding labels and stuff. And I guess this is an accidental new update, but for those of you who don't know, GitHub has expanded their user interface. So now we have labels for new contributors. And GitHub does a pretty good job at having a pre-release cycle that comes out every so often. I'm on the maintainers list, so I get like the sneak preview, so I sometimes don't know if my GitHub is going to look different than others. Hi Septic from cloudy Seattle, although I think it's kind of sunny today. It's pretty sunny out there. So anyway, TGIK repo. And you can come in and you can see our links. So the next thing I wanted to talk about was this article I found earlier today, which was setting up Kubernetes on Azure. Which, of course, I went through the exercise of creating a Kubernetes cluster on Azure before the episode started that we're going to use to play with the virtual kubelet here in a few minutes. And when I first did it, let's go in here. I'm going to open up the portal. I'll log into my Heptio account. When I first did it, I came into the user interface here, and I went to Kubernetes services, and I tried to come in and like add a cluster this way, and it kind of gave me some trouble. I remembered some like secret ninja moves from my days of working at on the Azure team on the AKS project, which is what we're looking at here. And I still kind of like ran into a couple of errors getting Kubernetes up and running. A quick Google, and I found this fantastic article. And for folks at home who are interested in setting up Kubernetes on Azure, this is the nugget. This is what you want to do here. So this thing worked great right out of the box. I ran these commands, which enabled the AKS preview so that we were able to actually access those bits of software behind the scenes. I came in and I created a resource group, and I gave it a name. In this case, our resource group is named, where do we go here? Should be Nova TGIK, which is, yeah, right here, TGIK. And then I gave it location, East US, which just kept the same because I remembered that one was a preferable region for Kubernetes. It spit out a little bit of JSON, and then this is like the magic command here that actually worked first time, hole in one, poof, Kubernetes up and running, which was AKS create, the name of my resource group, the name of my cluster, which I just named my name Nova, N-O-V-A, and I gave node count. I set that to 3, and I went ahead and did generate SSH key so I can SSH into those nodes in case anything happens. I didn't have to do this install CLI since I already had Kubectl installed on my MacBook. And then I just did AKS get credentials, and it appended my kubeconfig to the bottom of my existing kubeconfig just as I wanted it to do. And the whole process took less than 5 minutes. And I was like, there's no way this thing is working. And I pulled up my terminal and I ran my infamous kget-no command, which for those of you who don't know, I alias K for Kubectl and ino is short for nodes, and poof, AKS Kubernetes in like 5 minutes. It was really slick. So big shout out to all my homies on the AKS team. Like, good job. This actually worked really well. So let's go back to our repo and see what we have next. So the next thing I wanted to bring up was some other Kubectl tips and tricks. This first one, George tweeted this out earlier in the week. George works for us here at Heptio, and he tweeted out that we had some great Kubectl tips and tricks. And I was like, oh, I remember there was a cheat sheet once upon a time, but what's this we have here? And I started reading through it, and it was like documentation. And I was like, oh, there's some good stuff here. And about halfway through, I go, oh, wait a minute. This is the new discuss.kubernetes.io that was announced just recently. And I didn't even realize I was using it. And it's actually like this really cool interface where you can come in and you can join and you can contribute, and it kind of becomes like real-time documentation, but it's also like a chat venue as well, so that's really exciting. So we're gonna just, I created my first account, and I haven't actually like contributed to this yet, so we're gonna see if we can't come in and add a reply. Thanks for all the hard work. We are loving these tips and tricks on TGIK. So let's see if I can reply. And poof, there you go. I am now officially a contributor to the discuss.kubernetes.io project for the first time. So that was pretty easy. So anyway, there actually is some really good tips and tricks in here. The first one was, if you guys don't know, this -c is a new thing for a lot of folks who don't run multiple containers in a single pod. So that's handy to know. Then we have a couple of these --raw commands. Oh my gosh, what are people saying? So +1 for the TGIK repo. Eric says Kubectl, no more Kubectl. Yes, Eric, it's Kubectl now, and Kubernetes. And Marco says Kubectl for forever. I almost wore my Kubectl shirt today, just so I could say Kubectl and wear a Kubectl shirt while using kubectl. Hi, Brian from Denmark. No worries, we're just getting started. So yeah, we just have a couple of really great examples here and some folks coming in. Like here's my alias K for Kubectl shortcut here. So clearly not the only one who does that. But yeah, feel free to come in. You can, when you create an account, you can create an account with GitHub. So I just like clicked up here and did create new account and did login with GitHub, and it knew my name and had a picture, and then I scrolled down to the bottom and hit reply, and poof, it worked. Florian says, Kubectl tips and tricks, oh my god, how long have we come or how low have we fallen? That's pretty funny. So another one here is, this is like a little bit more of a formal cheat sheet that this, looking at the other tips and tricks kind of reminded me of this sheet from way back when that I haven't looked at in forever, and it's changed a lot since last time I looked at it, so I figured it'd be a good like refresher for folks. If you don't know this is here, it's in the official Kubernetes documentation. You can come check it out. It talks about all kinds of handy things to make you like a Kubernetes whiz and look awesome on live demos, particularly the Kubectl autocomplete, so you can get some really awesome tab hinting while you're doing live demos. The kube context I know is a big one. We're going to talk about this piece of software next that kind of solves the same problem, but here's the official Kubectl way of managing your different kube contexts. It talks about creating objects, gives you different examples of creating it from a directory or from a single YAML file, and it talks about how you can explain multiple objects at the same time or even interact with multiple objects at the same time. So it's really good just kind of to run through this every once in a while, and usually I pick up 1 or 2 tricks that I just kind of try out on a whim and they work. So yeah, this is a really great resource if you guys want to come check it out. So the next one is kubectx. So I usually have this installed on my Mac, but like I said, I just reformatted my hard drive, so I don't have it installed yet. So we're gonna just install it really quick live so you guys can see how easy it is to get this thing up and running. So installation, you do brew install kubectx, and then I already have my alias built for it. I just use ktx for my alias, but I should be able to run this. Beautiful, and let's see if my alias works. It does. So right now I have my Kubernetes cluster I created in Microsoft Azure called Nova, and I can rename, let's say this first one is one that was created with kubeadmin. If I wanted to rename that, I could do ktx, the new name, so we'll just call it this old cluster, and then the existing name of the cluster itself. Oop, did I do it wrong? It's, oh, new name equals old name. So there's a delimiter there. Sweet, so now if I run ktx, and I can ktx to old cluster, and poof, my kubeconfig is switched, and I can go back to my Microsoft cluster and kget nodes and bam, we can just switch kubeconfig really easily that way, and it gives you a kind of handy user interface for renaming things and keeping track of them. I used this on stage when I did my Kubeflow Arc demonstration, where I migrated some components over from Amazon over to Google with Kubeflow and Arc. Kubernetes, yeah, Jason brought up Kubernetes is another good one. We use that a lot in the moving monolithic calls, or moving monolithic application calls. That was almost in every piece of documentation we wrote as well. Jason, if you want to drop a link, like send it to me in Slack, and I can add it to the notes here in a few seconds, or you can send it to me on Twitter or whatever. Cool. So let's go back and check out next on our list of exciting updates. We have the virtual kubelet documentation, which I just added this here. We're going to look a lot at this in a second, so I'm going to kind of breeze past it, but it's there as a pointer for folks. Another one we wanted to shout out was some more great work the SIG ContribX folks are doing is meet our contributors. So this is the first Wednesday of every month. It's like behind the scenes, meet Kubernetes contributors and maintainers. It's basically a call just like this one. You can tune in on YouTube, and it's like an Ask Me Anything. You can contribute in Slack and ask contributors anything. I did it a couple months ago, and somebody asked me like what my favorite mountain was and what my first commit was like, and it was pretty exciting getting to interface with folks that way. So this is ran by George here at Heptio and Paris over at Google, and it's a really great program. So if you guys don't know about this, or if you would like to be starred or featured on this, feel free to reach out to the folks in the Slack channel there. Next up, I found this blog that a lot of people were talking about at GlueCon earlier this week, which is Under the Hood of the Operator SDK, which totally has my attention right now. I've been wondering about sort of a generic operator framework, and this looks like it's a really good sort of overview. Oh, Jason says Kubernetes is included with kubectx. Awesome. But this looks like it's a really good overview of what's going on and kind of giving you the play-by-play of the new operator framework that was announced at KubeCon from our folks over at Red Hat. So there's a pretty handy diagram here that explains how this whole complex system is going to come together, and how the operator is going to take that complexity and try to make it a little bit easier for folks to interact with, and how you can start to build out your own operators. And speaking of operators, Joe gave a really great keynote, and there was this one thing that he said that really kind of struck home with me, and I have never heard this phrase before, but I figured it'd be important to share with folks, which Joe was talking about the difference between controllers and operators. And he said he was able to describe an operator in one sentence, which was, an operator is just a domain-specific controller. And that to me was just like like, wow, somebody finally did it in one sentence. And Lockie over at Microsoft was at the conference, and he had the same reaction as well. So it's a very unique piece of code that behaves like a controller, but it's very specific to a single thing. You know, it's specific to MySQL or to Mongo, or it's doing some concrete task that's important to humans. So the operator SDK is going to take that and actually make that easier for you to interact with, and make it easier for you to build out one of these operators. So maybe we can get on one of these in the future. But anyway, if you want to come through and read this and learn more about it, the link is there. Next up, we have an update on Arc, our favorite backup and recovery tool. So we're here live on my Twitter, and it says we're starting to open meetings to design new features. The first is on replication of backup data. So the folks at Arc have a mailing list that you can join here in the Google groups, and you can start getting calendar invites and email notifications about design meetings that are going on. So you can come and you can join and you can contribute to Arc and help steer the shape of this open source tool moving forward. So we've already done a TGIK on Arc. I'm sure we'll do another one because the program is growing so much. But it's a really great opportunity if you're looking at getting involved in Heptio open source and nailing some of those sweet keys that we were passing out at the conference, the Kubernetes and Heptio mechanical keyboard. Feel free to join in on this project and get some commits in and see what the folks at Arc are up to. Another good discuss bit of documentation we had is this one that Josh at Red Hat put together that is last week in Kubernetes. And this is sort of a really great piece of documentation that's also a form of communication as well, that goes in and talks about everything that happened in this last week in Kubernetes, which is what we're talking about right now. He brings up the community meeting, what went on the community calls, which happen every Thursday at 10 a.m. Pacific. You can get the link from github.com/Kubernetes/community. he talks about the release schedule and the different various pieces of feature work coming up. So this is a really good resource. I haven't really seen anything this comprehensive written down yet in the Kubernetes ecosystem. So the fact that we're getting this every week is a pretty big milestone for the project and pretty exciting for you to come in on a busy schedule, at a glance, see what's going on in Kubernetes. And if you have any questions or notes, you can come down here to the bottom and click reply and throw in your 2 cents. Cool, so we're almost done and we're gonna start on the virtual kubelet soon. We're about 20 minutes in, so I'm trying to keep a good pace here. And the last one I wanted to bring up was this easy install Helm, which I spent a couple of minutes researching this. Our friend Paul, who brought this up on one of the moving monolithic calls, had brought this up when we were trying to get Helm installed on an RBAC cluster, and he had wrote these really convenient Helm install and Helm delete shortcut aliases that you can copy into your bash profile. So what's funny is I spent a couple of minutes, I looked these up, I found them, I added them to my bash profile, I deployed a Azure Kubernetes cluster and I did Helm init, and we weren't using RBAC, so I didn't need them anyway. But it's a really great article for those of you who want to get Helm up and running with RBAC. Okay, and it looks like we have some stuff going on in the chat. So let me just take a quick look here. Andy said, thanks for the plug. You're welcome, Andy. Is this on GitHub newsletter? Mind sharing the link later? So yeah, Florian, it's in the link to the discuss thing I just pulled up is in the TGIK repo, github.com/heptio/TGIKs. I think I can share links. Let's see if I can do this. github.com/heptio/TGIK. Bam, see if that works. There you go. So that's the link there. Thanks for helping out, Marco. And without further ado, I think it's time to start hacking on the virtual kubelet. And Eric had asked a question earlier, which was like, now are you actually going to be hacking on the virtual kubelet, or are you just going to be hacking on the virtual kubelet? And I think the word hacking is a bit of a marketing ploy here. We're not actually exploiting anything. The virtual kubelet, as far as I know, is fine. So we're not like exploiting anything. We're just going to be playing with it and doing a live demo. So that's what we were implying when we said hacking on the virtual kubelet this week. So let's pull up the virtual kubelet GitHub repository. I always like to start these things if I haven't started them already because I get handy notifications, but it looks like I already got to this one. And then I guess real quick, before we jump into the terminal land and seeing what's going on here in the repo, I can share a little bit of what my experience was like with the virtual kubelet from my days working at Microsoft and seeing how far it's come since like the initial discussions we had. So originally, I remember we saw like an internal demo that Brendan had done on the virtual kubelet quite some time ago. I think I was in the Boulder office. I don't know if we were still DS or if we had come over to Microsoft yet, but I'm pretty sure I was sitting in the Boulder office, and we got to watch Brendan do this demo, and like he did a kget nodes, and there was a node that was there that wasn't a real node, and we were all like, it didn't make sense, and then like had this big aha moment where it's like, oh, we're spoofing the kubelet. It's a node, but it's not a node. But Kubernetes thinks it's a node, but it's just doing everything the kubelet does, and it's not a node. So that project, it vendored everything off to ACI. And so that project, I think, later turned into what we see here, which is the virtual kubelet. So there used to be, let's see if I can find it. There was the, what was it called? I think it was the ACI connector was the name of the TypeScript repo. Oh, I might not be able to find it. Okay, it looks like it's no longer on GitHub. So I don't know what happened to that repository, but there used to be a repo of something that did a very similar thing that was written in TypeScript that then was later ported over to Go, which is this program we see in front of us. I think it was originally presented to the advocacy team, which I was on at the time, and I think we remember we were going to call it the fakelet for a while, and then virtual kubelet kind of came and took over. Okay, so Ria says it's a private repo now. Okay, it was called ACI connector. But yeah, so anyway, it's pretty interesting. Like, I always love a good piece of software when it kind of goes on a journey, and it turns into this new thing, because you know that it's been tested and it's kind of like they've made it through the evolutionary cycles. So to see something as complete as this is always really exciting. So we had a quick question, which is virtual kubelet cloud agnostic. The short answer is yes, and we're going to get more into that when we jump into the source code here in a second. So anyway, virtual kubelet /virtual kubelet, it's a Go repo. you can come in here and you can sort of see that the first bit of documentation kind of just echoes what I said earlier, which it's a Kubernetes kubelet implementation that masquerades, that's such a great word to use here, masquerades as a kubelet for the purpose of connecting Kubernetes to other APIs. So anyway, to answer your question, it looks like right now we have ACI, which is a Microsoft Azure product. We have AWS Fargate, which is of course AWS. We have HyperSH, and we have this new, let's pull it up here, the Azure IoT Edge Virtual Kubelet Provider, which is a virtual kubelet provider for Azure IoT, which I think Eric had mentioned earlier. This is a pretty new thing. So it is cloud agnostic, and I think it's pretty easy to write one of these implementations. And we're going to go and we're going to kind of look at the interface. And we're not going to write an implementation today, but we're going to look and see what it takes. So to explore the program, we have our good old main.go, and we have all of our top-level repository things. We've got our Go package. It looks like they're using dep. Good job. And then we have a couple of packages here, and we have our good old CMD directory, which I'm sure has some entry points for the program as well. But what I wanted to look at first was this diagram here that sort of explains how the virtual kubelet works. So in this example, we have the Kubernetes API going across the top, and we have a handful of real Kubernetes nodes running with it, which is what we have here. Running in the wild. We have a Kubernetes control plane, and we have 3 worker nodes. So that should mimic this diagram if we had, one more node here, which I think the number of nodes is irrelevant. And then we have this new virtual kubelet that we're going to run on the side. I think the way this is going to work in this demo is we're going to run the virtual kubelet on my local MacBook, and that's actually going to take my MacBook and use that as an intermediary computer that's going to re-vendor off to ACI moving forward. And then with the virtual kubelet, we can perform a couple of different actions. Like we can do node conditions, we can get pods, we can get the status of a pod, we can update it, we can even get the capacity in the operating system. So I was able to come in, and I'll bring you guys back to where I am mentally with this whole project, because I started to jump into it yesterday and then was like, you know what, no, I'm just going to do this whole thing live on TGIK. So if I fumble around a bit, we have our folks at Microsoft here to help me, and we're going to try to get some containers deployed into ACI using the virtual kubelet with Microsoft's managed Kubernetes service today. Whew, that's a lot. Hopefully we can get that all in. So here's where we are. So we have our Kubernetes cluster up and running. We are here in the virtual kubelet directory. And the first thing I did when I came in here was I took a look at the makefile. So we can come in and we can notice we've got a pretty lengthy makefile, but I searched for the string go build. I found we have this target here called go build. It calls this other target author. It echoes out building, and then we have our beautifully formatted go build command here on this line. So I went ahead and ran it. And I guess before I do that, I had to make a few changes. So I'm going to go commit my changes to a new branch. Eric says he's got a couple of additional diagrams. Okay, maybe you can open up a PR to the repo. See how handy it is? We can say that now. Open up a PR to the repo or drop an issue in, and we can merge those back into the README there, Eric. Anyway, I had to make a few changes to get this thing to compile earlier today. So my changes are here in my local directory. So I think what I want to do is commit these into a new branch, come back to the master branch, reset everything, demonstrate the error, and then I can show you guys the couple of one-liners I had to tweak to get it running. And I think it's just an issue because I'm running Go version 10.2. But anyway, we have some Go experts on the call today, so maybe they can give us a little more insight as well. So the first thing we want to do is we want to check out a new branch. So we're just going to call it TGIK demo. I'll call it Go 10 because I have a feeling that's going to be our imposter here that's giving us so much problems. And we can see what we have. I've got a couple of modifications in the cri.go file. And I'm going to go ahead and add that to our index, cri.go. And I'm going to do a quick commit. Adding changes to git program to compile for TGIK. Wham kablam. And now we can git checkout master. We can git reset hard. Actually, let's look at what our remotes are. Git remote -v. Okay, so I think I can reset from that. But yeah, that's what we want to do. So git reset hard origin master. Beautiful. So if I run a make build, Actually, before I do that, go version. Now let's do a make build. So if I run a make build, it's going to echo out building. And if I did this right, we should get a couple of interesting Go errors here. Oh, and it looks like I was buffering just a little bit. If folks can let me know if this compile is throwing off my CPU and if I just started buffering, I can not try to compile real time on the call. Okay, so anyway, it looks like we hit our first error here, which is we have some undefined syscalls, which last I checked, the syscall package was frozen. So if this is an issue with syscall package changing, that's kind of exciting because that means we finally unfroze the syscall package. And if we go back to our TGIK demo branch, git checkout, bam, we can see what I did here to change this. And I haven't seen anything in the chat in a few seconds, so if folks want to let me know that they're still seeing me, that would be helpful. I always get nervous with my CPU taking up too much, or with my program compiling and taking up too much CPU. Anyway, so let's see. It looks like somebody's outside the door. Wonder if it's the person trying to work in here, or somebody telling me that I went dead. But we can go to quick. Oh, video looks good. Thanks, Jason. You always got my back. So I remember telling Joe how to do this. We can zoom in here a little bit more, and I think it was tool windows, into presentation mode. This is what we want to do. And then we come up here, we close that, we zoom in there, and then I can go view, tool windows, project. Bam, I think that's what we want. So that should look good for folks at home. So I came in here and we had this error, and Craig confirms the video looks good. So we had this error down here, and we can see what I did. I really hacked this. Basically, all we were doing is we were getting some information out of the syscall package and returning a uint64. I just hard-coded 1024 and returned some value. We're not using the CRI provider in this call, so I figured that would be okay just to get things compiling and to give it a non-zero value there. And then the other thing I had to do was up here on line 668, we had pods and namespace. Nope, that wasn't it. It was one of these. There was a string somewhere in here. I can look it up and see it if we want to, if you guys want a line number. But where we were doing a %s and referencing a pointer to a struct. So the Go compiler was yelling at us. So I changed that to a %v, and the Go compiler was able to correctly expand that into the string, and the program compiled. So those are the two tweaks I had to make in the CRI provider. I can push that branch I just created up so that folks can at least see the delta and get the information there. But I was able to make those two changes and get the program to compile. So we're going to recompile it now, and hopefully my CPU doesn't take over by running a make build, and that should compile, and then we can actually start trying to run the program and see what's going on. And in the meantime, I'm going to open up that PR so we can see the delta here. So virtual kubelet, git. Oh, I'm not going to do it because I don't have my branches set up. So I'll do that after the call. I don't have my remote set up to open up a PR, but I will do it RIA, I promise. Just trying to find filler while we were waiting for our program to compile. Anyway, we're compiled now. And if we look here in the my IDE, we can see that we have this new directory called bin. And in the bin directory, we have the virtual kubelet binary. So we're going to move this virtual kubelet binary from bin virtual kubelet to user local bin virtual kubelet. And then, like I mentioned earlier, everybody calls this thing VK. So I want to be the first person. I'm sure somebody else has done this, but I'm going to claim to be the first person to alias VK equal to virtual kubelet. And I guess before I do that, let's make sure VK doesn't do anything already. Okay, yeah, it doesn't. I don't want to break anything on my system. Okay, so alias VK is equal to virtual kubelet, and bam, we're running the virtual kubelet. It's in our path, freshly compiled from master with a couple of small changes, and we've got the virtual kubelet program running. and let's see what is next in our little piece of documentation here. So it says we need to pass in a virtual kubelet provider and then equal that to your provider. And I guess this is probably a good opportunity for me to talk a little bit about various providers in Go programs, and we see a lot of this in Kubernetes and especially in the cluster API work that we're doing now. And it's a really interesting engineering problem to solve. Right now, if you look at how the cloud providers work in the cluster API and most of the cloud provider implementations that you see in and around the Kubernetes ecosystem, Kubecorn, Kops, these are all no different. They all have some concept of a cloud provider. Some people call that an actuator, some people call that an actual cloud. In this case, we call it a provider. And I think if we go in here, we can find, probably not here, but there's going to be an interface somewhere in the source code that describes what each of these providers need to satisfy in order to be a provider. Now the problem comes in is when there's a bug in the CRI provider, like the one we just saw, and we're trying to use the Azure provider, and we're getting conflicting problems, and the Azure provider isn't compiling because there's an issue in somebody else's provider. So that's one of many great examples of why you want to start pulling this stuff apart, at least this is my opinion anyway, but why you want to start pulling this apart and defining some sort of contract between two independent executables that will allow a common agnostic piece of code to interface with a cloud-specific piece of code. And we can probably use tools like Docker and Kubernetes itself to pull those together into a single pod and run two containers and do the orchestration and the mapping at the container layer instead of actually trying to do that at runtime using a flag or a switch. So there's different patterns and different things we can explore. There's a couple of great threads on the topic in the Kubernetes issue tracker where people are suggesting maybe we use Go plugins, maybe we can use gRPC, maybe we have some sort of like REST API type contract like we've used for the CNI interface and implementation. There's a couple of different ways to skin this cat, but I think it's, as these programs are evolving, this is going to be something that's really important for the Kubernetes community to look at and say, how do we start having cloud-specific code that isn't dependent on other cloud-specific code to work? Okay, so that's my rant on cloud providers. So anyway, if we go back to the top level, we can top level directory in our repository, we can see this interface here that we were talking about. So each one of those cloud providers is going to be implementing one of these provider interfaces, and each of these interfaces need to satisfy each of these methods described here. So we need to be able to create pods, we need to be able to update pods, delete, so on and so forth. So that's how you would go and you would write your own provider implementation to the virtual kubelet so you could start vendoring out pods in your own unique way. Looks like we have a question. We have the pluggable pattern for ELB, I suppose. This tool is useful for portability across providers, right? Yes. So the whole point of the tool is that we're describing the common level logic here, and then you can come and you can bring your own provider implementation to the table, and all your provider has to do is know about these methods here. So in theory, like create pod could really just wrap a bash script that does a Docker run, and you could write a bash wrapper and make that an implementation to the virtual kubelet. So interesting stuff here. So already I'm kind of wondering, this interface looks like it's very descriptive in nature, and I know the transaction between the kubelet and the Kubernetes API server is, it goes both ways. And so you'll need connectivity from the API server to the kubelet and back from the kubelet to the API server. And actually, I'm going to do my first .cam on this really quick. So let's see. How do I come over? Yeah, okay. So I'm going to use Joe's camera here. Okay, so you'll actually need the API server in Kubernetes, which is going to have TLS in front of it. And you're going to have some subset of kubelets. And this is a little known fact about the kubelet here, is each kubelet actually has its own TLS encrypted API server. And usually, they have their own group of certificates. So if you go and you look in the kubeadmin code, there's actually different phases for generating these certificates as well as the different certificates each of the kubelets gonna run as well. So the API server is going to need to be able to speak down to each of these kubelets to call the methods that we see in the virtual kubelet interface we just looked at in GitHub. But furthermore, we're actually going to need to go back the other way as well, because the API server is actually going to be listening to the Kubelet's TLS servers as well, so that we can do things like exec and log. So it's a sort of like unidirectional transaction that you can prescribe what you want the kubelet to do, but you can actually request information back from the kubelet as well. A really great example would be is if we took our API server and we said create pod, and it came over to the API server that the kubelet had, or I'm sorry, not the API server to the kubelet had. It said, you know, the kubelet was watching this API server and said we need to create a pod. The scheduler told it to create the pod. The pod is now running on this this host here. And then somebody said, you know what, I want to grab logs from that pod. So what happens then is the API server opens up a socket to the kubelet's API server. The API server is now a client, and we'll actually be able to get logs back from the kubelet back upstream. And that same pattern is how things like exec work as well. So I'm curious how the virtual kubelet is going to handle these unidirectional communication between both the kubelet and the API server. And if we actually want to go explore in the API server source code, we can actually go in and find the undocumented kubelet API server in all of its majesty, hidden in the secret bowels of the Kubernetes source code. So anyway, let's switch back to my screen here. So anyway, here is the kubelet interface for what the Kubernetes API server would be prescribing out to the virtual kubelet, with things like create pod and update pod. Okay, so that was my rant. So let's scroll back up, and let's see our first example here. It says, run the binary with the chosen provider. So I'm going to guess we can come in here and go into our providers directory, and I bet we can just do provider-Azure and see what happens. So we can do vk --provider, and I'm just going to guess this is the syntax. We'll see what happens here. Ooh, we got a nil pointer dereference on ACI.go on line 147. Let's see, I bet I can fix this really quick. Where was this at? Virtual kubelet providers, Azure, ACI.go. Okay. Azure, ACI.go, and that was on line 147. Subscription ID. Okay, this is great. Okay, so I bet there's some sort of, looks like we need to do some sort of authentication setting to get authenticated with the Azure web portal. I was wondering if we were going to hit this. So it looks like here we're doing OS get environment, and we're expecting these environmental variables to be set. So I have a hunch if we go ahead and export these environmental variables with working credentials, we'll be able to fix our nil pointer dereference and get the virtual kubelet up and running. So let's see if we can find some documentation on this anywhere. So get our terminal out of the way. Let's see, there's examples, there's charts, there's vkubelet. Is there like an Azure, can I grep for Azure? Container instances provider. So here we go. So we have a config file. Okay. The Azure Container Instances Provider allows you to utilize both typical pods and VMs and ACI. You can find detailed instructions on how to set it up using the ACI Instance Provider documentation. I think this is what we want to go through here. Okay, so this is what we looked at earlier. You can install the CLI. Okay, we have Kubernetes Helm installed. I mentioned earlier how I had set that up. So we should be able to do, let's just make sure it's running, Helm ls. And yep, okay, so Helm is up and running. We got that. Good old curl pipe to bash for, what is this, our friends at Windows? Maybe? No, this is Linux curl pipe to bash. Okay, Linux here. So for Windows, you can follow that to get the helm.exe. And if not, you can curl pipe to bash here. But this is what I think we want to do. So we want to do az account list o table. Yep, and we want to export. Here's our environmental variables we need to export. And I haven't seen anybody in the chat in a minute. So my anxiety is getting the best of me. So if somebody wants to drop a quick, hey, Kris, you're doing great, and the video is working well, that would be exciting. So yeah, let's get our subscription ID, and let's export that first. And I'm going to try to do this like a clean way in real time so that you guys don't see my full bash profile. But we should be able to, how do I want to do this? I'll just export it in this shell, and we'll just make this our magic shell. That's what we can do. Okay, so we want Azure subscription ID. Good. Thanks, everyone. So it's just weird because like you're sitting here and you're talking to yourself and you're like, man, it could be like that one time a couple of weeks ago when I'm in here for 10 minutes talking to myself and then I get a phone call that says nobody can see you. So yeah, thanks for the support, everybody. It means a lot to me. So anyway, Azure subscription ID. So we want to export that, and we can grab our Azure subscription ID from here in the portal.azure.com. So I went through, so if you guys don't know this, this is like from, a couple months at Microsoft working with the Azure team. You can actually customize these favorites here on the left. So I went through and like sort of created mine. I can get rid of these ugly AKS failures here. I went through and created mine that is sort of unique to today. And you can actually have like a custom little like markdown snippet here for like shortcuts and commonly used things in Azure. So anyway, you can customize Azure and change the colors. It's pretty cool. But you come in here and you can pull up, where is subscriptions? They should be in here somewhere. Maybe not. You can go to all services. It's right here in the middle. Subscriptions, yep. And we should have just the one, and you can click on it, and you can grab your subscription ID here. And there's even a little copy thing. So we can pull this up. Oh, Ria says there's also a quick setup which will enable you to avoid all these expert things. Ria, do you want to maybe drop a link in the GitHub issue tracker, or open up a PR and let me know when you're done, and I'll pull it up and we can try to run it real time. And in the meantime, I'm going to keep chugging away with exporting these environmental variables here. So we can come in and we want our Azure subscription ID. And then we want to install, what is this? The quick setup for the ACI connector. Now, do we have to install another piece of software as well? Oh, I see. Okay, so I think this needs to happen on the Azure side. Oh, Ria says it was on the same page I was just on. Okay, I'll go back and check in just a second. Let me finish this thought on this piece of documentation here. The Azure CLI can be used to install the ACI provider. We like to say Azure's provider implementation for Virtual Kubelet is the ACI connector. For this section of VK-specific ACI provider will be referenced to use the ACI connector. If you continue with this section, you can skip between the sections, schedule a pod in ACI. So I think what we want to do is we want to run the Linux ACI connector here. I think this is the command we want. So let's go ahead and pull up this terminal, and let's see what we got here. Okay, so install ACI connector. Oh, she says I'm doing the right thing. I'm on the right one. Bah-ha-ha-ha-ha. Thanks, Ria. Okay, so resource group, we're going to put this in the same resource group we've put the rest of our Kubernetes cluster in. It seems like a good idea to me. So the name, the AKS cluster name, which is the best name in the world, Nova. We're running on Linux, and the connector name, we're going to call this, we're going to call it Nova connector. Nova dash, we'll do it NovaCon, because that just sounds like a cool thing. Plus, obviously, we need a Kris Nova tech conference in our lives. And the ACI resource group, auto-generated AKS cluster resource group. Now, I wonder if this can be the same resource group as the one defined above, or if I need a second resource group here. We're going to try first with the same one, because I just like keeping everything in the same resource group. But if this doesn't work, hopefully by the time I get around to it, somebody could have suggested a better alternative approach. So let's run this command. Resource group Nova cannot be found. Interesting. I thought I had, let's pull up our Azure portal here. Over here on the left, we have resource groups. Ah, Nova TGIK, that's right. That's right, that's right. Nova is the name of the cluster. So let's do Nova TGIK, and then if you guys don't know this trick, you can do, oh, might not work because I have a weird keyboard right here. Yeah, it doesn't work. You can do Alt left and right in a proper bash shell, and you can skip a whole word. But because I'm using a larger keyboard right now, my Alt isn't working. Anyway, Nova TGIK, and I think I misspelled that, Nova TGIK. So go to the end of our line and run that and see what happens. Deploying the ACI connector for Linux using Helm, error failed to download, hint, running Helm repo update may help. Helm repo update, wham kablam. I just installed Helm today, so that's usually should have been done. But since this is like effectively a brand new computer, we're still kind of doing some of the setup-y stuff here. So let's run this again. Deploying the ACI connector, still failed to download. Hint, Helm repo update. This smells like a Helm repository issue here. So let's see what our what is it, Helm repo? I think, yeah, Helm repo list is the command I want. And then do we have to maybe add the repository? Oh, it's been so long since I've used Helm this intimately. Let's pull up the docs and see what the docs say. Is there anything on Helm in here? Helm woes strikes again. Schedule a pod in the ACI section. Install the Linux ACI connector. Okay, so it says you need to specify the ACI resource group due to a bug in the AZ CLI. The resource group is the auto-generated. To find the name, navigate to the Azure portal resource groups, scroll down and find the name that matches the MC AKS cluster name. AKS RG location. Okay, that's a bit confusing. Not really sure what string we're looking for there. But let's see if we can't find any documentation here on Helm. Helm release, Helm. That's how you install Helm on Linux. Deployment into your cluster. Okay, I think we're getting off in the weeds here. Let's go back up to the higher level documentation and see where we're going. So I'm wondering if we were actually trying to, in that scenario, trying to deploy the ACI connector into the actual Kubernetes cluster itself, which I'm trying to run it locally. So let's go back and let's get back on that track. And then hopefully in the meantime, somebody can drop a link or two in the chat here that might help us. Or not a link, but a pointer in the right direction. So anyway, so we came back and we tried to run our VK provider Azure, and we got this. So let's go back and let's start exporting these environmental variables. All right, so we pulled up our source code and we did Azure subscription ID already. So now let's do Azure tenant ID, which I've already got just from the months of working at Microsoft. When I created my service principal, I also catted it to a local text file, so I'm able to get all this stuff pretty easily. So this should go pretty quick, which is a good trick for folks at home who need to create Azure service principals. Always cat that to a text file on your local file system so you can use it later. So anyway, Azure tenant ID, we can save that command, and we can cat, what is it, service principal.json. I'm going to show you guys my secrets, but I'll nuke this after the call anyway, so it's not going to be a huge deal. So we can do Azure tenant ID, wham kablam, and that's going to be this string here. And then we also want to get client secret. So export Azure client secret, which is this password here. And then last but not least, we want to grab our client ID, which is going to be it's this one here. It's our app ID. That's the one. So this always kind of was like frustrating for me, which was the service principal calls all of these directives one thing on the command line, but every piece of Azure documentation always calls it a different thing. So in this case, our tenant ID is the tenant, the client secret is actually the password, and the client ID is actually the app ID. But anyway, that's the mapping that you need to remember. And I have a hunch this should work now. If we just check everything is there, we should be able to export case-insensitive grep for Azure, and yeah, we have all kinds of Azure secret-y stuff running there. So now let's get our vk command back here in the stack so we can pull it up. Vk provider Azure. And we're still getting some nil pointer dereferences. Okay, so before we look at debugging this, let's see what is going on in the chat. Okay, so Ria says, no, you're good, that's the one, you found it. Different one. Okay, so this is kind of hard to grok here because the timing is so off, so big, long, complete sentences are always appreciated. But anyway, so yeah, ACI resource group is the auto-generated, and acronyms are also frustrating. I don't know what, I'm assuming RQ is RQ or RG. RG is probably resource group. That AKS creates no charts in the repo is what Antoine asked. And Gabrielle says, check the bash script. And Ria says, yep, we have charts in the virtual kubelet repo for just Azure, which you can use too. Okay, so I think what we need to do is we need to figure out what the charts are actually trying to do, and then what we would be trying to do by running the virtual kubelet here in our local file system. So let's go and let's just check out the charts and see what's going on in there. We all know that Joe likes to inspect YAML, so let's go and have ourselves a good YAML inspection session in honor of Joe not doing TGIK this week. So we can come over here to charts. Let me pull up this directory here. Okay, so it looks like Helm was trying to download the tarballs here, and we've got two charts. We've got virtual kubelet and we've got virtual kubelet for AKS. So let's look at virtual kubelet for AKS. So the first thing we have is we have Microsoft Virtual Kubelet. I got a thumbs up from Antoine, so it looks like we're probably on the right track here. Looks like we're missing a lot of directives here, which is I'm assuming is going to be okay. And we have a chart here, and in our templates we have a deployment, and we have our secrets. So looking at our YAML with Go text templating for Helm, we have some names, we have our image, which is defined in that other values.yaml file we looked at. We've got port, Azure tenant ID, subscription ID. Okay, so I think what's going on here is this Helm chart is attempting to deploy the virtual kubelet to the existing Kubernetes cluster to run in the cluster. Which we can fall back to that if we want to. I was really hoping we were going to be able to run it on my local file system and actually get my computer to basically behave as a broker for ACI. So we'll try to hack on my local file system a little bit more and see if we can't get this thing up and running. And if not, we'll default back to trying to install this Helm chart. So to go back to our original plan of running from the local computer here, let's see what's going on in Go. So we run our vk command -- provider, let's go to Azure, and we are getting nil pointer dereference on 135. So let's see what's going on here. So in our providers, Azure, ACI.go, 135. Did I miss one? Azure client ID? Did I not specify the Azure client ID? So I have Azure client ID here. That looks fine to me. I'm wondering if it's OS get in reads at runtime, so we don't need to recompile the program. How are we still? Is AZ Auth not created? Oh, I bet that's what's going on. I bet AZ Auth is nil. Aha. And we'll just exit the program here because we're just going to debug this really quick. So let's do a make build and bin virtual kubelet -- provider Azure. Let's see what this does. So real quick while we're waiting for this to run, if anybody on the virtual kubelet team can let me know if I'm on the right track with thinking that the Helm charts are actually going to be deploying the virtual kubelet to run in Kubernetes as a pod, and if there are any caveats or reasons why running it on my local file system might not be the best approach to demoing the virtual kubelet. I'm kind of new to the new paradigms behind the virtual kubelet here, so any help with the higher level direction would be greatly appreciated. And sure enough, we were able to find out that that auth struct wasn't being initialized in the Go code. So let's go and see why. I have a hunch it has to do with a provider config file, something or other, and I bet we can create one really quick if we just go and look and see what the code's doing here. So we want to get rid of this if statement, and we want to go up and make sure that we're not importing that OS package that we don't need anymore. And it looks like my IDE was able to take that away from me. So we called new ACI provider. We defined the type of AZ auth, and we say if auth file path. Here we go. So we have Azure auth location and AZ credential location. So these were defined in the Helm chart as well, and I bet they're going to be critical to define in order to get the virtual kubelet up and running. So let's look at this Azure auth location. Eric St. Martin says you can run it on your local host. That's how I debug it and work on it. Okay, so we still got, we've only been working on this thing for an hour, so I'm happy to continue to hack on it a little bit more and show off some of my Go skills and really jump into the source code here, hopefully encouraging people to come and help out and contribute to the project and get a virtual kubelet running on my local file system. So we want to figure out what types of values ACS credential location is expecting. And maybe Azure auth location as well. So Ria says, so yes, VK will run as a pod with the charts or AZ AKS install connector command. Okay, so that's starting to glue the bigger pieces together. So what Ria is saying is we could have had a Helm chart. One option of running the virtual kubelet is to use the Helm charts here in the local repository, which I have a feeling is going to be pretty easy to run. And that would actually run the virtual kubelet as a pod in Kubernetes, and then the Kubernetes API server would detect the virtual kubelet as a node, and we would create a virtualized kubelet inside the cluster itself. The other way of getting it up and running is to use this AZ AKS install connector command, which is what I was trying to do earlier. And that seems like it's just another way to go about installing the virtual kubelet connector on your cluster, but using the Azure command line tool instead of Helm chart. And then the third option is what I think I'm going for here, which you guys know me, I always have to pick the hard way of doing things, is to actually try to use my local host to develop on and to actually get the virtual kubelet running that way. So let's finish reading what the rest of Ria had to say, which was the experience you were going towards as developer on VK1. So yeah, she's just confirming that I'm taking the developer approach here and not necessarily the user approach here. But you can do either. So we'll spend a few more minutes here hacking and trying to figure out getting the program up and running, and then we'll default back to trying to get the Helm chart deployed and getting the AZ Azure command line command working as well. If anybody wants to vote for one or the other, I'm happy to prioritize that one if we think that one would be a little more interesting. So in the meantime, let's see if we can find any clues in the documentation here. So we have a question, can the virtual kubelet be deployed on a bare VM or is it always in a container? Ria says VK is a pod that looks like a node in Kubernetes. So I think, yeah, in this case, I'm going to be running it as a local Go program, but then we can later rerun that as a pod if we push it up to a registry, which I think our folks at Microsoft has already done, and then deploy that into Kubernetes somehow. Okay, so let's see what's going on here. So is there an auth file? We have auth there. We have auth location. So testing the Azure provider client. The unit tests for Azure require a credentials JSON, and the file exists in the root directory that you have Azure auth location set to the credentials file. You can generate the file by following the instructions listed in the README for that package. So I think we want to do, yeah, this should work here. And then what's the name of the JSON file we expect it to be in? Okay, so in credentials.json. Okay, so let's go here to the top level. Yep, we're there. And let's go and let's create this JSON file. So we're going to call it mycredentials.json. Yeah, and Eric confirms my suspicion that you can run the virtual kubelet anywhere as long as you can connect back up to the Kubernetes API server. So this, we'll call this TGIK creds .json wham kablam. I don't know, somebody said that at this last conference and I've been saying it all week long. I can't stop saying it. So while we're waiting for that to run, we can then export our Azure Auth location. This is starting to make me feel warm and fuzzy. I feel like we're getting close here. Very good. So now we can export Azure Auth location is equal to, oh, I spelled it wrong. So let's do this. Move tgig creds.json to TGIK creds.json. And now we can run our export command. And that's going to be TGIK creds.json. Yep, thanks, Mike. You got it too. So now let's run our make. We'll recompile it, although I don't think we need to. But since we already have the command in our history, we can spend a few seconds of compile time for me to grab some Diet Coke and see if this thing will get up and running now. Waiting for it to compile. Dum-da-dum. Okay, resource group cannot be empty. Please set ACI resource group. So I bet that's another export. Let's do ACI resource group is equal to Nova TGIK. Then we're not going to make the same mistake of recompiling. We're just going to run our binary again. Region cannot be empty. Okay, so good. So at least now the program is starting to kind of like say like, okay, you're getting close. You need to start setting these other things. So let's export our ACI region is equal to, I think it's East US is the value we want. Try it again. I think we just got really close, everyone. This looks like exciting things are happening. Okay, so let's look at our logs here. So the virtual kubelet logs start about right here. Looks like it detected our kubeconfig, and it's creating a pod. Oh, cool. It's doing all kinds of stuff. It looks like we are getting an error, though. Let's see what we have. Preview, got HTTP response status code 409, error code, missing subscription registration. The subscription is not registered using the namespace. See this URL for how to register subscriptions. But just in the meantime, let's split screen here. Let me zoom in a little bit and then resize. Okay, that looks like it should be okay. Let's just see if we've been able to register as a node while it's still running. Yeah, we have. Okay, cool. So virtual kubelet's up and running on my local workstation, which is pretty exciting. And I think it's probably, for now, I'm going to ignore these errors. And if we have time at the end, we can actually go check out that URL and see if we can get these errors to go away. But this, to me, is a really, really big sign. So working in Kubecorn, working in Kops, working in kubeadmin, actually getting the API server to detect a node is kind of like the very last step in getting a node up and running. A lot of times you'll have a kubelet running, maybe it's configured close but not quite all the way, or the API server is having some trouble detecting it. So it looks like it's running, the service looks happy, but then still the API server says no, a node's not running. But it looks like we were able to skip past all that and get straight into the API server going, yeah, the virtual kubelet is running. So now let's go ahead and let's see if we can't schedule a pod. Oh, this will be exciting. On my local MacBook from Kubernetes API server running in Microsoft Azure. It looks like we have a question. Can you run Kubectl describe node on the virtual kubelet? Yes, I can. That's a really great question. K describe node, the name of our node. And you know, before I do that, I'm gonna just kind of scoot this thing over here on the left, so we can just kind of see if it fails on us or anything goes wrong. But I just want to kind of look for the fact that it's moving there on the left side as I'm going through the rest of the demo here. This is just, I'm just talking about how I think about Linux. But yeah, let's go ahead and run our describe node here. And let's go and see what we found. So yeah, the question is, I wonder how much of a real node functionality this is. And that's a really great point to bring up. And now that we have this thing up and running, we can kind of start to inspect the virtual node, which is really just my MacBook, and see what we have going on. So we'll start all the way up here at the top. So we have a name. It's running as an agent. It's got some familiar looking labels on it. So this always bothered me, the unschedulable directive. I really would rather see schedulable is equal to true here, but I think there's a whole history behind that. Anyway, we can schedule to it, which looks like you can't, but you can. It says the kubelet is ready. It has sufficient disk available. So these are the traditional kubelet checks that you see. Usually if the kubelet fails, it's on one of these. That's just been my experience. So Ria says issue number 71 is what we're hitting with the error you're getting. Okay, cool. So we've already got that issue, and I think it's being worked on, which makes me happy. So yeah, we have sufficient memory, and our disk pressure looks okay, and we were able to create a route. So over here on the left, looks like we're missing an internal IP. We were able to get, ooh, this looks interesting, 100, GI, I hope that's not gigabytes, gigabits maybe, of memory. We have 20 CPU, and it looks like it thinks it's running Linux AMD 64, and we're running the kubelet version 1.8, which is interesting because I thought we set up a 1.9 Kubernetes cluster earlier today. Looks like the kubelet does have a pod cider here, so I wonder, quick question for the folks at Microsoft. Is this pod cider address advertised by the API server, or is this built into the virtual kubelet program and it created it for itself? I'm wondering where I got this pod cider from. Seems like it might be something that the cloud provider would have to figure out somehow, but wondering where that is coming from. And it looks like we're in the kube system namespace, and we've got a couple of warnings here. Cannot create route. For node virtual kubelet after some amount of seconds. So it looks like a handful of warnings, but nothing's really jumping off the page here at me. And then I think following up on Ria's talk from GlueCon earlier this week, I think one of the things I wanted to kind of point out about just the virtual kubelet in general is because it is running virtually, it's not going to be able to do everything a node traditionally has done in Kubernetes. I think some of the backwards transactions that we talked about earlier with the execing and the logs are going to be there, that we'll be able to pull those out of a vendor. But because every vendor implementation is going to be different, you're now at the risk of whatever the vendor supports or whatever implementation you support, that being able to satisfy different features of the kubelet itself. I think a really great example here is how would we map a potential service to one of these pods running on the new virtualized kubelet, which we're about to do here in a second and see what happens. But just some food for thought there, that as this program starts to grow, we're going to come into some really interesting different situations of how we're going to start to connect different virtual kubelet implementations back upstream to the broader level kubelet interfaces that the rest of Kubernetes kind of expects to be there. And it looks like we have our first comment here that says that the pod cider is a virtual range. Everything's virtual. It's virtual kubelet. And let's see what Eric said. So he says right now it does a lot of the reconciliation status logs from pods, etc., but still has a bunch of things to be added for full kubelet compatibility. So I think Eric and I were just almost saying the same thing there as far as how much of a node the virtual kubelet is. So I think you really see the value in the virtual kubelet when it comes to things like the KubeCon talk I did with David Aronchek over at Google, starting to do ML and batch processing and the really quick and dirty, I need a pod and I need it now. And that sort of lends into this sort of concept of batch or burst processing. And I remember hearing a lot about this at Microsoft, this concept of oh, we're running some workloads on Kubernetes, and oh no, it's Black Friday. And all of a sudden our workload spiked through the roof, and we can't create enough virtual machines, or we don't have enough hardware in our data center to support this spike. So having the virtual kubelet could be there to be really nice to kind of act as a spillover, right? To kind of help you handle those burst workloads that come in. And we were not going to have all the functionality we would have with a traditional Kubernetes pod, but we can at least keep our systems online long enough to maintain stability and keep our systems up and running, which is important. So, burst up into a service like ACI ACI or Amazon's Fargate, run some ephemeral workloads up there. Maybe we go through a little data loss. Maybe we don't, and then we bring that back down as the workloads decrease, and we restabilize back on our existing infrastructure before. So I think that's a really cool pattern that we're going to be able to see with things like the virtual kubelet. So anyway, let's go and let's try to schedule a pod on the virtual kubelet, running on my local MacBook, and then I have a feeling my brain's just going to start to kind of explode with all kinds of different things I want to do now, because I've always dreamed of my MacBook being a kubelet in a Kubernetes cluster, and opening up my laptop and then joining a Kubernetes cluster, and then the API server scheduling containers on my MacBook so that I can use them for various things. But this is me and my weird way of wanting to run Kubernetes. Anyway, I remember seeing an examples directory. So let's go see if we see anything up here in the examples directory. So looks like we have an Nginx pod, we have a Nano server, and we have an IIS pod YAML files here. And let's see what we're doing here. So we do define a toleration, and we give it the key azure.com/ACI, and it says no schedule. And it looks like it's a pretty simple Nginx server. So I'm wondering if we can vendor up to ACI from my MacBook using this YAML manifest here. So let's take this and let's Kubectl apply it. So where do we want to go? We want to go to source github.com virtual kubelet, and we want to k apply -f examples nginx pod.yaml, and I don't think we needed to edit anything, but let's go check one more time here in our examples directory. Okay, so we have, it's a pod, it's Nginx, it's going to pull the official Docker Nginx container image. We're going to poke holes in 8443, DNS policies cluster first, and we have a node selector, which is the virtual kubelet my ACI connector Linux. So let's see if we can run this. We created a pod. What namespace was it in? Okay, so it's in the default namespace. Let's describe this pod. Describe Nginx. Oh, PO Nginx. And I really want to do an O wide on this, but let's describe it first. Okay, so it says failed scheduling, which I think is okay. Let's see what it says here. It says pending. So I wonder what our logs are saying over here on this side. Error creating pod kube proxy. I wish I could grep through these logs. Let's see here. Let's see where it's trying to schedule it, and then we can check Azure and see maybe it's being created in Azure right now, and we're just waiting for the rest of the system to catch up. So let's do kget PO one more time. Do O wide. So it's still pending, and we don't know what node it's on yet. So let's just go and take a peek in the Azure portal, see what's going on here in ACI, so container instances. So we don't have a container instance yet, so something is going on, and we're not able to schedule up to ACI. And I'm wondering if it's an authentication problem or what could potentially be going on here. So RIA says check issue number 71. So I'm wondering if we need to fix issue number 71 in order to schedule up in Azure. So let's pull up our Chrome again. We'll go to our virtual kubelet, and let's go to the issue tracker. Grab some Diet Coke on the way, because that's just how I roll. Pull up any old issue, and we'll come into issue 71 here. Oh, Ria says I need one more cred I have to add in. Any idea which credential I would need to specify would be helpful as well. This looks pretty wordy. I can try to read through this really quick. To add the service principal, I've already done that. Can't seem to create the assignment. Created the IAM contributor on resource group and getting, wow, this is SP Boyer, not SD Boyer, who is a friend of mine from open source. So I was like, whoa, Sam changes his GitHub name, but it's just a different person. The PIM error is different from the authorization error. I get the error from the AC command line now. Copy the number after service principal. In your AKS resource group, add an IAM contributor role to the service principal number. So I think this is what we want to do here. So I think this is the solution. We just got to kind of figure out what the right combination of steps we need to do are in order to make this happen here. So to add the service principal, so you cat the JSON file, which we have on our local file system, and you copy the number after service principal. So let's see what this looks like. So let's get some more wiggle room here. So it was service principal. So I don't see service underbar principal here defined. Let's see what this says. In your AKS resource group, add the IAM contributor role to the SP number. Interesting. Okay, Ria, if you could do me a favor and be a little more verbose on a good next step, if you have anything in mind, that would be helpful. Deterring some of this is a little bit challenging because I haven't really looked at any of it before. But I think we want to do this IAM configuration. It's just a matter of figuring out what this means. So let's put issue 71 on the side, and let's go back into the source code and see what's going on here. When in doubt, read the source. So let's go back to our providers in Azure and ACI.go, and I wonder if we grep for IAM. So not in here. So we have Azure Auth location. So yeah, so Ria says add that role on the right track, and then we have somebody else say, is it somehow related to RBAC? Which I don't think we're running RBAC on this cluster, so I'm not really sure, or I don't really know if it's going to be an RBAC issue. It looks like we had to go through and we had to define these environmental variables. So I'm just wondering, we don't have cloud set, but I'm wondering if cloud is inferred. ACS file path, we have auth location set, but we don't have credential location set, I don't think. So I think maybe we need to do the credential location. Let's see. Again, let's run our grep-i command, export, grep-i Azure. Okay, so those are defined in my bash profile. Our other ones are going to be over here. So let's stop the virtual kubelet. Let's do this. Let's kill this thing. And let's ensure that our environmental variables are defined here on this side. grep-i, there we go. Okay, so we have these, and we have auth location, but we don't have credential location defined. So let's look in the docs for ACS credential location. See if this is going to get it for us. Okay, so the charts do expect it to be there, and it is here in the ACI connector.go, but no more clues in the source code anywhere. Let's try to read this a little bit more in detail and see if we can't come up with any other clues. Okay. So this is the error we're getting. The next error is a service principal issue looking for a workaround. To add the service principal, you cat this file, copy the number after service principal. So I guess when I created my service principal, my file might have been created slightly different. And that's why I'm not able to find this number after the service principal. In your AKS resource group, add the IAM contributor role to the service principal number and delete the pod. Operation failed with bad request. I was seeing what this AZ command was here. created the IAM contributor and resource group and is now getting failed to find any PIM data. You should be good to go. That error is because the cert isn't being passed through for Kubectl logs, but I don't know what OW means. The connector will work fine. The PIM error is different from the authorization error. Try ACS service principal. Try what with ACS service principal? I don't really know what that means. Anyway, so let's hopefully we get some clues from our folks over at Microsoft, and let's come back a layer and let's see if we can't deploy a Helm chart here. We've already been on for about an hour and a half, and maybe we can get 2 virtual kubelet nodes running and see how the difference is between running on my local file system and running on a pod in Kubernetes, and we can compare the two different nodes, and then hopefully we can actually schedule a workload out to the virtual kubelet on either my local host or the Helm chart deployment that's going to be running in Kubernetes when we get done. So let's go back up here to virtual kubelet, and I think we can go to charts, and we can do virtual kubelet for AKS. So I think the Helm syntax here is going to be Helm install charts, and then we want virtual kubelet dash AKS. Let's see what that does. Failed to download. Is it Helm install -F? There's a way where you can run from your local. Well, there's a lot here. So Helm install -F. My values.yaml. So yeah, I think we want to do, I think this is right. I think we want to do Helm install -F charts virtual kubelet dash. Why do we not have? Oh, for AKS. Okay, there we go. See what this does. This command needs 1 argument. Oh, so I think we do, isn't it dash name? Call it TGIK VK? Maybe I do. Helm install TGIK VK -F charts. Hint, failed to download. So I think we had it right there. Maybe I just add it to the end without the dash name. Let's try that. Bam. Go to the end of our command. TGIK VK. Error, failed to download TGIVK. Oh, so, Nicholas says no -F, but you have to reference it relationally, so it just doesn't assume the prefixing / there. Bam, thanks for the clue, Nicholas. Greatly appreciated. Okay, so now let's do a Helm LS. And we have ideal Sasquatch, and let's see what pods are running. So it should be in the default namespace since we didn't specify otherwise. So okay, so this is running. Okay, cool. So let's get our logs here. I didn't specify any auth anything, so I'm wondering if it pulled it out of my local file system, out of my local environmental variables that were set on my local file system, or if we need to go and define that somehow. And I think that's what the documentation we were looking at earlier was doing. So let's get our PO. Actually, let's get logs and see what's going on in the logs here. And we can follow those. Okay, so failed to find any PIM data in the certificate input, and it says our node is registered. So I bet we have 2 virtual kubelet nodes running now. Awesome. We have, well, no, we just have just the one, but it's been up for 54 seconds. Okay, so it has the same name, so Kubernetes is thinking it's the same node. So now we can go in and we can try to reschedule this pod and see if it'll get rescheduled on the newly created virtual kubelet here. So let's kill Nginx, K, delete PO, and because it's a deployment, the scheduler should reschedule it for us automatically. And let's get our pods and see what's going on now. Oh, because was it not a deployment? It was a pod, wasn't it? So let's apply it again. So it was examples, what was it, Nginx pod? Yeah, Nginx pod. That's what's going on. Okay, so now we can get our pods. Been up for 3 seconds. And let's see what's going on here. pending. Okay, so not scheduling yet. Interesting. So let's see. Let's see what's going on. We describe this pod. K describe PO, name of the pod. And here we go. We failed scheduling. Nodes are available. Node network unavailable. Failed scheduling. Interesting. And then let's go and let's look at these logs over here and see if they give us any more clues. Reading ACS credentials file. So this is etc ACS azure.json, and it said loaded ACS credential file successfully. So it's getting cred somehow. And it says node virtual kubelet with the OS type Linux has been registered. And it says TLS failed to find any PIM data in certificate input. So let's go back to this issue number 71 and see what we got going on here. Norman says, what's going on in the Azure portal? You know, that's a great question. We checked that earlier. Let's do a quick refresh and see what's up. Still no instances being scheduled. Oh, I was going to go back to our friendly issue 71 here. And we had some PIM. You'll get a PIM data error if you don't feed a cert, but that's fine if you don't want to use Kubectl logs on ACI containers. So this thing should be working. And then the only other PIM, created IAM contributor and resource group and getting failed to find PIM data. So let's look in the documentation here and see if there's any clues on installing this Helm chart. So we have these directives that are not set, but they should be being pulled from that Azure credentials file. Yeah, it looks good to me too, Ria. So it's pretty interesting. Why it's not wanting to schedule? Maybe it's a dreaded case of eventual consistency, and we're just waiting for some things behind the scenes to take over. Nope, we're still pending our Nginx pod here. Interesting stuff. Cool. Well, I mean, at this case, I think we've demonstrated that the virtual kubelet, kind of how it's supposed to be running, the concept of vendoring out to a party like Fargate or like Microsoft Azure's ACI, and we've learned about the different interfaces you can satisfy to create your own virtual kubelet and to come and create your own provider in the program. And we've learned that you can run it locally and use your local workstation as a broker to one of these container services like Fargate or ACI. And you can also run it in a pod in the cluster itself, which to me really that's the real virtualness of it, is we have some set of nodes running in the cluster, and then we deploy a pod, and the virtual kubelet kind of comes from thin air and it's virtualized, and now we have this magical new node that's actually going to go and vendor out to these services outside of the Kubernetes cluster itself. And then just by defining a simple line in your pod spec here, this node selector Kubernetes IO host name is equal to the name of the vendor you want to describe. You can actually control which pods are going to get scheduled on which nodes. So this is a pretty powerful construct, and I'm really excited to see this project moving forward. And I'm going to tinker on it a little bit afterwards to try to get this up and running with Microsoft Azure ACI and actually get one of these examples deployed. And the beauty of the new TGIK repository is after I get all this done, I can go and backport and document all this, and it will become a resource moving forward. So looking forward to seeing questions and answers. I'm going to open up an issue or follow up on issue 71 with my experience here, and hopefully we can figure this out moving forward. And then hopefully folks can come and contribute to the TGIK repository with any questions they had or suggestions or ideas for future episodes moving forward for TGIK. And without further ado, I think, I'm going to call it here. It's been about an hour and 30 minutes. And yeah, I'm going to let everybody get back to their weekend. So thanks for joining, everybody. It was great to see you. And yeah, we'll talk to everybody next week.